Hi mathematicians, welcome to the Unit 6 Lesson 9 video on medians of triangles. This is a very quick lesson. We're going to talk about what medians are in terms of triangles, just briefly go over the proof, and then do an example of how we apply it. And then that is it. Very quick lesson compared to others. So first up, what are the properties of a median of a triangle? So a median of a triangle is a line that goes from the vertex of a vertex of a triangle to the midpoint of the triangle. So you see here DB is the same size as CB here, and this line right here is our median of our triangle. Okay, so AB, when we're talking properties here, AB is a segment that connects a vertex of a triangle to its opposite side. So just like we said, opposite midpoint specifically, just like we said. Because in this case, point B is a midpoint, it cuts DC into two equal smaller parts. So we have DB and CB. And then AB goes through the inside of the triangle. So specifically when we're talking about medians, it goes through the inside of the triangle. Now, something special about triangles, right? They have three sides. So you can draw three different medians when we have a single triangle. So one is this point AB, and then we could have this point here DE, or this line here DE, and then CF would be our third point. And if I drew this perfectly, they would cross down the middle. Let's see an example of this. So more properties when we are talking about medians of triangles. So medians of triangles meet at a single point, so they are concurrent, and the point that they meet is called the point of concurrency, or also a centroid. The properties of centroids, they'll always lie on the inside. So, right, our medians are all on the inside. They'll always lie on the inside, and it cuts our lines into ratios of 2 to 1. That means that basically 1/3 of the line is going to be on one side of the centroid, and then 2/3 of it are going to be on the other side. So here, right, the centroid cuts this one into thirds, it cuts this one into thirds, and then it cuts this one into thirds as well. It's not quite an even disbursement amongst the lines. I should say even, meaning it's not an even split. It's a 2 to 1. So we have thirds that we're working with. Its center of mass is this centroid point. So just keep that in mind moving forward if you continue to study them. Now, how do we prove that medians of triangles intersect at a single point? Your text goes into this very in-depth, but ultimately what we do is we look at the weighted average amongst all of these points. So like I said, it splits it kind of into thirds. So we kind of look at points and do the same, and ultimately we are given this formula here to find the average of the centroid. So if we have a triangle with 3 points, we're once again working in that coordinate geometry, right? We have these 3 points. If we take the average of each one of our x values and our y values, this gives us the point of our centroid, or that middle point. So in our example here, we have 3 points. We have the point 2, 4. We have the point -3, -1. And we have the point 7, -3. Now, if we simply add up all these points, so we have 2 minus 3 is -1, -1 plus 7 is 6. And then we have 4 minus 1 is 3, and 3 minus 3 is 0. Okay, so if we take this and then we divide our sum by 3, we get the location. Now, sometimes in examples, you're going to be able to simplify this so it's not a fraction, and sometimes we can't. This is an example in which we can simplify it. So 3 goes into 6 2 times, so 6 divided by 3 is 2. 3 goes into 0 times, so 0 divided by 3 is 0. So that means that our centroid for our triangle here is located at 2, 0, and it's this point right here. So if I were to draw lines going from my vertices to the midpoint on the other side, all these points would land at 2, 0. So just remember, we add up all of our x's, we add up all of our y's, and we divide each one of them by 3. Sometimes we'll be left with fractions, and sometimes we'll be left with nice whole numbers. Hey guys, that is it for this lesson. Like always, please reach out if you have any questions, and until next time.